Top 10 scientists claim that plastic waste has unexpected applications. Plastic waste is becoming more and more of a global problem. The planet is flooded in plastic, as we all know. Literally, if we continue on our current path, analysts predict that by 2050 there will be more plastic in the ocean than fish. Scientists, on the other hand, have been hard at work coming up with innovative and creative ways to get rid of all those plastic bags, bottles, and straws. Rather than recycling plastic waste, these businesses have developed new ways to convert it into something else entirely. For example, used plastic has been turned into vanilla flavoring, protein powder, and blocks that are stronger than concrete. Number 10. Making vanilla flavoring from plastic bottles. Scientists are attempting to solve the problem of plastic bottle waste while also addressing the world's massive demand for vanilla flavoring, thereby slaying two birds with one stone. Vanillin, which is either obtained naturally from vanilla beans or synthesized using chemicals, is responsible for the odor and flavor of vanilla. As a result, vanillin can be found in a wide range of products outside baked goods. The substance can also be found in a variety of meals, cleaning goods, and cosmetics. As the global need for vanillin develops, plastic bottles may be the answer. Two researchers from the University of Edinburgh in Scotland have discovered how to convert terephthalic acid into vanillin using E. coli bacteria. Terephthalic acid is the main component broken down from polyethylene terephthalate plastic bottles. Because the chemical compositions of terephthalic acid and vanillin are so similar, the researchers were able to convert the molecule to vanillin in a short amount of time. Number 9. Plastic may be transformed into jet fuel in less than an hour. Although chemical recycling of plastic waste generates high-quality products and has been possible for some time, the massive amounts of energy required and the lengthy processing periods make it prohibitively expensive. Washington State University researchers, on the other hand, have developed a way for transforming plastic into jet fuel in under an hour. The researchers converted polyethylene, a common sort of plastic, into jet fuel and other high-value lubricants. This was achieved by the creation of a catalytic technique that converted around 90% of the plastic into fuel. The task took them less than an hour to complete. The technique was not only faster, but it also used less energy than previous methods. The team is now working to perfect their conversion procedure so that it can be used in the real world. Because of the lower temperatures and shorter processing times, their discovery could be a game-changer in the chemical recycling of plastic. Number 8. Plastic might be able to aid with sand scarcity. Given the abundance of beautiful beaches around the world, it may be difficult to believe that the world is experiencing a sand shortage. Sand, on the other hand, is widely used in construction and manufacturing as well as in concrete production. The sand from the beach, on the other hand, is too salty and the desert sand is too smooth. As a result, rivers are routinely dredged for building sand, resulting in a host of environmental hazards. As a result, several governments have made sand mining illegal, creating a peculiar sand mining underworld dominated by sand mafias. Researchers are looking into this and have discovered that plastic garbage may be collected, cleaned, shredded, and crushed into sand when mixing concrete. With this method, up to 10% of the sand in the concrete mix might be replaced while preserving the same properties. Because concrete includes about 25% sand, replacing 10% of it with plastic might have a substantial impact on lowering worldwide demand for mafia sand. Number 7. Fertilizer made from plastic. According to estimates, only approximately 9% of plastic waste is recycled. The rest gets discarded and winds up in landfills or drifting in bodies of water. Experts want to solve the problem by figuring out ways to reuse plastic rather than discard it. A team of researchers from Tokyo Institute of Technology has devised a way for chemically turning bio-based plastics into fertilizer. Bio-based plastics are a better choice for the environment than petroleum-based plastics. Using the ammonolysis process, the researchers generated urea, a nitrogen-rich molecule from ISB, which is a byproduct of PIC, a bio-based plastic. plant growth trials were done to analyze the fertilizer, and the researchers discovered that plants fed the pig fertilizer grew better than plants fed regular fertilizer. Number 6. T-shirts made from recycled plastic. To alleviate the world's plastic bag problem, how about turning plastic bags into high-tech workout clothing that can be easily recycled? A study published in Nature Sustainability aims to do this. The work turned polyethylene, the most commonly used plastic today and the type of plastic used to make plastic bags, into a wearable fabric. According to researchers, the fabric is made by weaving polyethylene fibers into textiles on industrial looms, which are less hazardous to the environment than traditional textiles such as wool and cotton. The fibers can be dyed in a variety of colors before weaving. These fibers allow water to pass through rather than rejecting it like plastic does. This means that during a workout, perspiration will not be retained within the clothing but will instead drain out, making the textiles suitable for activity. Polyethylene clothing can also be washed in cold water, reducing the demand for hot water and so helping the environment. Number 5. Plastic can be used to generate electricity. What if, rather than polluting the oceans, plastic waste could be converted into a chemical that could be used to power plants and electric vehicles? Researchers at Singapore's Nanyang Technological University (NTU Singapore) discovered that they could convert plastic waste into formic acid by using sunlight. Formic acid is a valuable chemical that is used in fuel cells to generate electricity. The chemists used a photocatalyst powered by sunlight to create a sustainable and environmentally friendly method of transforming plastic garbage. To achieve high heat levels, this technology does not require the use of fossil fuels. The team is continuing striving to improve the process and break down plastics in order to produce fuels such as hydrogen gas. Number 4. Plastic is now being used as a detergent. Researchers identified a way to generate a liquid from plastic waste that may be used to make detergents in a different approach that employs cleaner methods for breaking down plastic waste rather than consuming a lot of energy. Researchers from the University of California, Santa Barbara, the University of Illinois at Urbana-Champaign, and Cornell University discovered a mechanism to break down polyethylene into smaller molecules without using high temperatures or generating greenhouse gases. The scientists utilized a catalyst to remove a little amount of hydrogen from the plastic's polymer chain, which they then used to cleave the carbon chain into smaller pieces. To break the chains, the hydrogen must be consumed as soon as possible, leaving enough energy to generate fresh hydrogen. After numerous rounds, the researchers arrived at a liquid that might be used to make detergents. Number 3. Plastic milk jugs have been used as super durable bricks. Nzambi Mati of Nairobi, Kenya, turns trash that other recycling facilities can't use into sturdy plastic bricks such as sandwich bags, milk jugs, and ropes. Yenge Makers uses a sand and plastic combination that is fired to high temperatures before being squeezed into bricks. You might be surprised to learn that her plastic blocks are actually stronger than concrete. This product is remarkable in that it is made from materials that would normally end up in landfills due to its inability to be recycled. The bricks are made of high-density polyethylene milk and shampoo bottles, low-density polyethylene cereal bags and sandwich bags, and polypropylene ropes and buckets. Because neither the technology nor the materials are expensive, Mati can keep the cost of the bricks low, making the product affordable to Kenyans. Number 2. Food is made from waste plastic. Would you eat a protein powder created from a thrown-away plastic bottle? 2 professors from the University of Illinois Urbana-Champaign and Michigan Technological University believe that someone will. Their research attempts to alleviate both world hunger and waste overflows. Ting Liu and Stephen Techtman received the Merck KGaA Future Insight Prize for their work in metabolizing plastic garbage with bacteria to turn it into food. The researchers achieved this by breaking down plastic waste and feeding it to bacteria that love plastic. As the bacteria consume the plastic, more bacteria cells are produced, which may then be dried and turned into edible protein powder. This begs the question of whether buyers will accept a food product that was made from plastic garbage in the first place. Number 1. Bringing plastic back to its original form. Plastic degrades over time, which is one of the most major challenges in recycling materials. It is impossible to recycle plastic permanently. Recycling plastic garbage does not prevent it from being disposed of in a landfill, but it does postpone the process. What if scientists discovered a technique to break down plastic waste chemically and return it to its original chemical components? The materials might then be used to create entirely new plastic products. Plastic gets more difficult to process and degrades when it is melted and reused. Its polymer chains eventually break down and can no longer be utilized, thus they are destroyed. Chemical recycling will be used to break down the plastic to its original elements, according to scientists. Instead of ending up in landfills, it can be recycled to generate new, higher quality plastic products.